Hi guys, let's talk about population standard deviation. This looked like a tricky one coming up that you were ready for. If we have 5 participants of a 200-meter dash and they had the following finishing times, we're going to calculate something called the standard deviation, but we're doing the standard deviation for the entire population. This is everybody that we're studying. It's not a sample group, it's all the participants from this group. If we were doing a regular standard deviation, you would see this symbol, and the difference would be, I'll show you in a minute, but we would divide by n-1. So the population standard deviation is noted like that. And what we do is we take the numbers, we do the actual number minus the expected number, which happens to be the mean or the average. And we square that, and we add up each number doing the same thing. And then we're going to divide by the number of things that we have. So this is for a population, which just means if you're doing a statistic for the entire population, you're going to divide by the actual number of things that you have. If we're doing it for just a little sample group, we adjust it a little bit to make it a little bit more accurate for the sample. So we'll do, let's say here we have 5 things. If this was a sample group, we wouldn't divide by 5, we would divide by 5 minus 1 or 4. So here's the math you're going to do. You're going to go 32, that's our actual number, minus, actually need to calculate the average number, so I'm just going to add those up. 32 in my calculator plus 27 plus 30 plus 28 plus 28 divided by 5. And so I have this little symbol right here. It looks like a little cursive U. Is called a mu, like a cat goes mew, and it means mean. And our number here is 29. So we're going to divide, the n is going to be 29. So 32 minus 29 squared plus 27 minus 29 squared plus 30 minus 29 squared plus 28 minus 29 squared. Notice that squaring is going to make all these positive. Sorry, I'm running out of room here. We're going to have another one of these 28s minus 29 squared. We get all of that, we're going to divide that by 5. So I'm just putting this in my calculator. I'm literally going to put the entire thing in parentheses, 32 minus 29 parentheses squared plus parentheses 27 minus 29 squared plus parentheses 30 minus 29 squared plus parentheses 28 minus 29 squared plus 28 minus 29 squared. I'm going to hit enter, and then I'm going to hit divided by 5, and I get 3.2. And this is what we call the population variance. It is this symbol. Got our little population squared. And so to get the actual population standard deviation, I'm going to take the square root of the number I just came up with. So in our case, it's going to be the square root of 3.2. So I'm going to do that in my calculator. Shift, square root, shift, answer, enter, and I get 1.788854382. And it says round your answer to 2 decimals. So I'm going to call that 1.78, but the next number is an 8, so I'm going to make that a 9. So 1.79. Oh, I don't get to enter that. I wanted to be able to check myself. Well, That's the way it is. Oh, here, we'll hit explanation, and we should be able to check my answer. There we go. So the square root of 3.2 must be the same thing as 16/5. 1.788888 is 1.79. If you wanted, you could look at this. This is the actual formula, but I like to just think actual minus expected squared of each single item, add those all up, divide by n, then take the square root.